So, hello friends, a very good morning to all of you. Hope you all are doing good. So, in the last class, we have discussed about hyperbola, right? Exercise 1. But that exercise was not yet completed. So, we will take the remaining questions from that exercise and we will complete that, that first part, like first session, okay? So, okay. So this is question number 13. So I hope we have already done up to this question number 12. Okay, right. This is the subjective part, right? Without options. So we will take these questions. I think 7-8 questions are there. We will finish it. So what it is saying, find the equation of the hyperbola whose foci are 0, plus minus root 10 and which passes through the point 2, 3. Okay, so the coordinates of focus is provided, right? So let me write it as S1. So our first focus is 0, root 10, and our second focus is what? 0, minus root 10. Is it okay? And one more thing, this ellipse, what we have to find, that ellipse is passing through this point. Suppose I am saying that point as P, so coordinates of P is 2, 3. So that ellipse is passing through this point. Okay. So seeing the coordinates of this focus, if you observe, seeing the coordinates of this focus, you can say our ellipse will be of this form. Our ellipse will be of this form. X square upon A square minus y square upon b square is equal to what? Minus 1. Why? Because the x coordinate of the focus is on y-axis, right? And the y coordinates is varying, no? So it will be conjugate. It will be conjugate our required ellipse, right? Let me write it as our required ellipse. Our required ellipse will be conjugate to, will be why I'm writing ellipse, required hyperbola, right? Required hyperbola. A required hyperbola will be conjugate to this hyperbola. X square upon A square minus y square upon B square is equal to 1, right? So we can say the ellipse will be of this form. Our ellipse will be of this form. What is asked in the question? Okay, so hope this is clear to all. Now, a few conditions are given, like this ellipse is passing through this point and its focus coordinates are provided to us. Okay, so let's try to solve it. Okay, so what is the focus of this ellipse? We used to give focus by 0, PE, right? So we can say this thing, PE is equal to root 10. I am taking one focus only. So PE is equal to root 10. So square it, we will have B square, E square is equal to 10. Is it okay? Now, B square, what is the eccentricity of this? Eccentricity of this conjugate hyperbola, we used to give it by 1 plus A square upon B square, right? A square upon B square is equal to 10. So here if you take B square LCM, it will cancel this B square and we will have this A square plus B square is equal to 10. So this one equation we got from this focus coordinates, right? Now one more information is given. This ellipse is passing through this point, right? This ellipse is passing through this point. So it must satisfy the equation. So it must satisfy the equation of the ellipse. Sorry, I am saying ellipse or what? This hyperbola will must satisfy, this point will must satisfy the equation of this hyperbola, right? So let me put that. So we will have 4 upon 2 square means 4 upon A square minus 9 upon B square is equal to what? Minus. Okay. So I'm taking LCM. We will have a square b square in denominator. Here we will have 4b square minus 9a square is equal to what? Minus 1. So 4b square, we can write b square as 10 minus a square. Okay. Minus 9a square. And this thing, when it comes to left hand side, we will have plus a square. Again, I will substitute the value of b square as 10 minus a square. This will be equal to what? 0. So finally we get 40 minus 4a square minus 9a square plus 10a square and minus a ka power 4 equal to 0, right? So this will become a ka power 4, okay? Then 13 minus 13 and this thing plus 10 minus 3a square, right? So minus 3a square means plus 3a square we can write here, plus 3a square, and this plus 40 will become minus 40. So what I have done, I have added the like terms and I have taken negative sign common. Okay. So now we can factorize it further. So here you can say let a square is equal to x. So it will be a quadratic in x as x square minus 3x minus 40 equal to 0, right? Now split the middle term and it will be further factorized as x square. Okay, this will be plus 3x, no? Plus 3x. So 45 and 8 and 5, right? So x square plus 5 or 8x minus 5x minus 40 equal to 0. So x into x plus 8 and minus 5x plus 8 equal to 0. So we get x plus 8 into x minus 5 equal to 0. Okay. If that is the case, our x must be equal to minus 8 or x must be equals to 5. Now, what is our x? X is a square, no? So a square is equal to minus 8. So this value is rejected. A square cannot be equal to minus 8. This must yield some positive result, output. So we can say this a square, this will be valid. So a square is equal to 5. Once we got the value of a square, what will be our b square from this equation? From this equation, our b square will be 10 minus a square. That is nothing but 5. So our a square is also 5 and our b square is also 5. Now put the value of this in this equation of equation of hyperbola. So it will become x square upon 5, right? X square upon 5 minus y square upon 5 is equal to minus 1. So this will be our required values. Okay. So based on the informations provided, we just proceed and we got this result. Okay. So coming to the next one, question number 14. It is saying find the equation of the hyperbola whose foci are 10, 5 and minus 2, 5 and eccentricity is 3. Okay, so coordinates of focus is provided to us and eccentricity of the hyperbola is also given. Now we have to write the equation of the hyperbola. Okay, so let's take this focus as S1 whose coordinates are 10, 5 and let me write second focus as S2 whose coordinates are minus 2, 5 and eccentricity of this hyperbola is what? 3. So these three things we know. Now, if you observe here also the y coordinate of both the focus. So y coordinate is what? 5. For S1 also it's 5 and for S2 also it's 5. So let me draw one rough diagram. So it will be a lot easier to understand. So I am drawing a rough diagram for this hyperbola. So this is our, suppose this is our x and y coordinate. Okay. And I will draw now y equal to what? We can take this x-axis a bit down. Now I will draw y equal to 5. So this will be our y equal to 5 line. Okay. Now, see, suppose if I say this is my y-axis, okay, and this is my x-axis. Now, here it is saying, okay, let me draw that first. So basically, this coordinate, this S1 is given as what? S1 is given as 10, 5. Okay. And here is some, here is our S2, second focus, whose coordinates is -2, 5. -2, 5. And here will be somewhere here. Somewhere here will be the center, right? Here it will be the center of the ellipse. Sorry, again I am saying ellipse, center of the hyperbola. Okay, somewhere here. Now, if you observe our hyperbola, the conjugate axis, right? Sorry, the transverse axis of this hyperbola is parallel to x-axis, right? The conjugate axis of this hyperbola is parallel to x-axis. So we can say our hyperbola will be of this form. Our hyperbola will be of this form, x square upon a square, right, minus y square upon b square is equal to 1. This is sure. Our hyperbola will be of this form. Now, what will be the center? What will be the center of this hyperbola? The center is the midpoint of this S1 and S2, right? So our center will be basically, center will be -2 plus 10 upon 2 and what? 5 plus 5 upon 2. So our center will come out to be, let me say it as C. So our center will be 4, 5, right? So I am writing that here, 4, 5. Okay. So what will be our hyperbola? अगर इसका center 4, 5 है, right? So our hyperbola will be of this. The equation of hyperbola will be, in place of capital X, I will write x minus 4. So it will be x minus 4 square upon a square, right? And minus, in place of this capital Y, I will write y minus 5 is y minus 5 squared upon b squared is equal to, is it okay? Now, how to find this value of a square and b square, right? This is the next task. So if you see this distance, the distance between this center, this distance between the center and the focus, this used to be, for this hyperbola, for our standard hyperbola, this distance used to be AE, right? This distance used to be AE. So we can say this AE is equal to what? Let me call it as C, CS1. CS1. Right? This AE must be equal to CS1. Now, what is our eccentricity? Eccentricity is given as 3. So let me call it as 3. And what is the distance? This CS1. CS1 is 10 minus 4, right? 10 minus 4, that is equal to 6. So from here, we get the value of A as what? 2. We got the value of A as 2. Okay. Now, we got the value of this A. We have to find the value of B. So we will use this eccentricity thing. So we know for this hyperbola, eccentricity is 1 plus B square upon A square, right? And we know the value of E, 3, that is 9 minus 1, 8, 8 times A square. 8 times A square is equal to B square. So our value of B square will be what? 8 into 4, that is 32. So we got the value of B square as 32, and from here we get A square as 4. So simply put this, substitute the value of A square and B square in this hyperbola. So our required hyperbola will be, x minus 4 ka square x minus 4 square upon a square. A square is 4 and minus y minus 5 square. Y minus 5 squared upon b square. B square is nothing but 32 and that must be equal to 1. So this is our answer. This is our required equation of hyperbola, right? So I hope it is clear. Okay. Now let's take this 15th one. Prove that the straight lines x upon a minus y upon b equal to m and x by a plus y by b equal to 1 by m always meet on a hyperbola. Okay, so eliminate this m and you will get the locus, right, of that intersection. So our first line is this: x by a minus y by b is equal to 1. This is our first line. And x by a plus y by b is equal to 1 by. This is our second line. So what I will do, I will multiply 1 and 2 and we will get this x by a minus y by b into x by a plus y by b is equal to what? M into 1 by m. So from here we get a minus b, a plus b, that is a square minus b square. A square minus b square is equal to what? 1. And this is nothing but the equation of hyperbola, right? This is nothing but the equation of hyperbola. X square upon a square minus y square upon b square is equal to 1. Our standard hyperbola. So definitely these straight lines always meet on the hyperbola. This is nothing but hyperbola, right? So it has been proved that these straight lines will always meet on this hyperbola. Okay. Now let's take this next one. Find the center, eccentricity, and length of axis of the hyperbola 3x square minus 5y square minus 6x plus 20y minus 32 equal to 0. So let me first write this equation of hyperbola. This is 3x square minus 5y square minus 6x plus 20y minus 32 equal to 0. Okay. So it is not written in the standard form, right? So I will try to make it of that form, right? So what we can do, we can take these 3 common from here, these 2 terms, right? So we will have this x square minus 2x, and I will take again this minus 5 if I am taking common from these 2 terms. We will have y square and minus 4y. Is it okay? Minus 5y square plus 22y. Plus 20y. And this 32 remain as it is. Now what I will do, I will try to make it a perfect square in this bracket. So I will make x square minus 3x plus 1. Okay. And here we can make it as perfect square by adding plus 2, right? So it will be y minus 2 square. But what we have added additionally, we have to nullify that also. So in here we have added plus 3. So I will so I will subtract 3 from here. And here what I have done, 5 and minus 10, no? So plus 10, right? Plus 10 are equal to y square minus 4y. So 2 into, okay, this will be 4, no? Why I am writing 2? So this will be minus 20 we have added here. So I have to add this plus 20. No. This will be y minus 2 squared. This will be x minus 1 squared. Okay. But y minus 2, no. So earlier it was good in it. Good only. Right. Y square, let me see it. minus 5 into y square minus 4y plus 2 only, no? So 2 into 2. Here we will get plus 2 only, not 4. So y square minus 4y plus what? 4 plus 2 or plus 4. Just a minute. So this will be y minus 2 squared. Okay. So y square plus 4y. Sorry, minus 4y and plus 4. So I have to add 4, not 2. So minus 32, okay. And from here what we get? Plus 3, then minus 3 here. And what I will do? Plus minus 20 means plus 20. Plus 20 equal to 0. So it will become 3 into x minus 1 chi squared minus 5 into y minus 2 chi squared. Okay, and what we will get here? Minus 35 and plus 20, that is minus 15. Minus 15 equal to 0. Is it okay? Check it once. Yeah. So this will finally we can say this 3 into x minus 1 squared minus 5 into y minus 2 squared is equal to 15. Okay. Now I will divide by 15 on both hand sides. We will have this x minus 1 square upon 5. Okay. And minus y minus 2 square upon 3 is equal to 1. So now we are getting this hyperbola in our standard form, as of our standard form, where center is what? Center of this hyperbola will be 1, 2, right? Is it okay? So, okay, that we have to identify here also. This is what asked in the question. So the center of this hyperbola will be x minus 1 equal to 0 and y minus 2 equal to 0. That is nothing but x is equal to 1 and y is equal to 2. So our center will be 1, 2. Okay. Our center will be 1, 2. Now next, what is asked? Eccentricity. So eccentricity square, we already know that for this type of hyperbola, our a square comes out to be 1 plus b square upon a square, right? So it is 1 plus what is b square here? It is 3. And what is a square? 5. So it will be 5 plus 3, 8 upon 5. Okay. So our eccentricity will be under root of 8 by 5. Now length of axis. So this transverse axis length is what? 2a. And what is the length of this conjugate axis for this hyperbola? We used to give it by 2b. And 2a means what? 2 times a. A is root 5. Okay. And 2 conjugate axis is 2b. So b is what? Root 3. So 2 root 3 will be our conjugate axis. So this is the center, this is the eccentricity, and this is the length of the axis of this hyperbola. Is it okay? So fine. Let's move to the next question. This is question number 17. Question number 17. Find the eccentricity of the hyperbola conjugate to this given hyperbola. Okay. So the given hyperbola is x square minus 3y square is equal to 1. Okay. We can write it as x square upon 1 minus y square upon 1 by 3 is equal to 1, right? So what will be the conjugate hyperbola? What will be the equation of hyperbola which is conjugate to this? Conjugate to this hyperbola. What will be the equation of that hyperbola? The equation of that hyperbola will be basically x square upon 1 minus y square upon 1 by 3 is equal to minus, right? Earlier it was used to be plus 1, now it will become minus. So I hope this conjugate thing is known to all of you, right? For our standard hyperbola, x square upon a square minus y square upon b square equal to 1, right? If this is our hyperbola, its conjugate is given by x square upon a square minus y square upon b square equal to minus. Okay. And what is the eccentricity for this conjugate? The eccentricity is given by 1 plus a square upon b square, right? So our we can find the value of a square from here, since a square and b square is known to us. So 1 plus a square is 1. And what is b square? B square is 1 by 3. So it will be 1 plus 3, that is nothing but equal to 4. So we can say the eccentricity of this conjugate hyperbola is what? 2. Okay. Let me remind you, E cannot be negative, right? Because it's the ratio of two distances. So never write E as negative. So this is our answer. So, okay, the eccentricity of the conjugate hyperbola will be 2. Now, see this question. For what value of this lambda does the line y equal to 3x plus lambda touch the hyperbola 9x square minus 5y square is equal to 45? Okay. So this hyperbola is given as 9x square minus 5y square is equal to 45. Okay, let me divide it by 45 on both hand sides. I will have x square upon 5 minus y square upon 9 is equal to 1, right? And what is the line given? Line is given as y is equal to 3x plus 3x plus lambda. So suppose we are having this line y is equal to mx plus c, okay, and we are having this hyperbola x square upon a square minus y square upon b square is equal to 1. So this line will behave as a tangent to this hyperbola if c square is equal to a square m square minus of b square, right? This is the condition of tangency. I think this type of questions we have dealt in earlier lecture also, right? So what we have to do, this is the condition of tangency. So the c square must be equals to a square m square minus b square. So we will compare the same thing here. So this lambda square, y is equal to mx plus a, the line given is in this form only. So our lambda square must be equal to a square. What is a square? A square is 5. And what is the value of m? The value of m here is 3. The slope of this line is 3. So this will be 5 into 3 chi square, a square m square, and minus b square. B square is 9. So our lambda square will be equal to 5 into 9. So 45 minus 9, that is nothing but equal to 36. So the value of lambda comes out to be plus minus 6. Okay. So for these two values of lambda, this line will behave as a tangent to this hyperbola. Touch the hyperbola means what? It is behaving as the tangent for them. Okay. So this was our question. This is our question number 19. I think this is the last question for this exercise. So here also it is asking to find the equation of tangent to the hyperbola 4x square minus 9y square is equal to 1, which is parallel to the line 4y is equal to 5x plus 7. Okay, not an issue. We have to write the equation of tangent to this hyperbola whose equation is 4x square minus 9y square is equal to what? 1. So I can write it as x square upon 1 by 4. Okay. Minus y square upon 1 by 9 is equal to 1. So here a square is equal to what? 1 by 4. And b square is equal to what? 1 by 9. Right? And the given line is 4y minus 5x. 4y minus 5x minus 7 equal to 0. Right? Now our tangent should be parallel to this line. Okay. So we can assume our tangent to be what? The equation of tangent to be 4y minus 5x plus some constant equal to 0. This will be our equation of tangent, because then only these two lines will be parallel to each other. Is it okay? So further you can simplify it and write it in the form of y is equal to mx plus c. So we can say this as 4y is equal to 5x minus k, or y is equal to what? 5 by 4x minus k by 4. So this is our equation of tangent, but we don't know the value of this k. Right? So we will apply the condition c square is equal to a square, m square minus b square here also. So applying that condition of tangency, we will have k square upon 16. This is equal to c square is equal to a square. A square is 1 by 4. M square, what is m square? What is the slope of this line? 5 by 4. So this will be 5 by 4 chi square. A square m square minus b square, that is 1 by 9. I hope it is clear to all. So from here, if you see, we will have k square. I am multiplying by 16 on both hand sides. So it will be 25 upon this 16, and that 16 will get cancelled out. We will have this by 4 and minus 16 upon 9. Okay. You can further take LCM. This will be 36. 9, that is 2 to 5. And 4. So 64. Okay. So minus karo. 5 में से 4 जाएगा 1. And this we will have 22 minus 6, 16. Okay. So 161 by 36. So we got k square as 161 upon 36, or the value of k will be plus minus root 161 upon 6. So this will be the value of k. Now what will our equation of tangent then become? Our equation of tangent will be this 4y minus 5x plus minus this thing root 161 by 6 equal to 0. You can further take LCM also. So this will be 24y and minus 30x plus minus root 161, right, is equal to 0. So this is the required equation of tangent. Okay. Now it is also asking the point of contact. Point of contact. So basically point of contact, you can find it. No, you are having the equation of this line. You are having the equation of tangent. You are having the equation of hyperbola. So anyhow, you can solve these two equations and you can have the point of contact. But let me, I'm not going to solve, but our point of contact comes out to be this thing. A square m upon c with plus minus sign, and our y coordinate comes out to be b square upon c. So you can solve both the equations and you can get, or you can simply apply this formula and you can have the point of contact, right? So I think this is the last question. So we are done with this first exercise, right? We are done with this first exercise. We will be soon back with this second one. Second exercise of hyperbola, right? So this is all for today. This is a small video, but I will try to make the second one also. I will try to upload that second video also as soon as possible for this second exercise, right? So this is all for today. And one more thing, in the last video, I have discussed about setting goals, right? So I told you to set your goals high. Okay, once you are set, once you are done with the setting thing, what if you have set? Is it enough? Is it enough to achieve that goal? No. So you must have that willpower, right? You must have that determination to achieve that goal. and that can be backed up by your hard work, that can be backed up by your dedication, right? You have to live that goal basically. It's not enough that someone says, sir, I will become, I want to become IAS officer, I want to become a great teacher or mathematician, anything. But that will not help. Like, you have to work upon that day and night. You have to live that goal. Then only you can achieve, right? So मैं वीडियो बना दिया, आप लोग सोच रहे हैं कि मतलब सर ने कहा था कुछ सेट कर लो, अच्छा सा गोल हो जाएगा, तो ऐसा नहीं है. यू हैव टू वर्क ऑन दैट. आपको उसके लिए प्रयत्नशील होना पड़ेगा, ठीक है? उसके लिए आपको कड़ा मेहनत करना पड़ेगा. तो once you are ready with these things, once you are having good willpower, then you can easily achieve that. Okay. So this is all for today. This is all for today. Okay. Tata. Goodbye.